Have you ever wondered how comets are formed? Comets, those icy celestial bodies that streak across our night sky, have been a source of wonder and intrigue since time immemorial. These cosmic voyagers with their fiery tails are not just stunning to watch but also hold secrets about the very origins of our universe. The formation of comets is a captivating topic that draws us deeper into the mysteries of the cosmos. These icy bodies are time capsules preserving the primitive debris from the solar nebula, the cloud of gas and dust from which the sun and the planets originated. Unraveling the process of comet formation helps us understand the early solar system and the conditions that led to the birth of planets, including our own. As we embark on this cosmic journey, we'll explore the birthplaces of comets, their ingredients, their voyage to the inner solar system, and their life cycles. Today, we are diving into the fascinating world of comets. Comets, those icy visitors that streak across our skies, originate from the outermost regions of our solar system. Imagine the solar system as a grand cosmic neighborhood. Now let's travel far beyond the planets we're familiar with to the outer edges, where the sunlight is just a faint twinkle. Here in these frigid reaches we find the birthplaces of comets, the Kuiper Belt and the Oort cloud. The Kuiper Belt, named after astronomer Gerard Kuiper, is a vast region of space beyond the orbit of Neptune. It's a cosmic junkyard, filled with icy remnants from the dawn of our solar system over 4.5 billion years ago. These remnants, called Kuiper Belt objects or KBOs, are the raw material of some comets. They're often described as dirty snowballs, a mixture of ices, such as water, methane, and ammonia, and rock. Further out we find the Oort cloud. This is a hypothetical, massive, spherical shell enveloping our solar system, almost a light year from the sun. It's named after Jan Oort, the Dutch astronomer who first proposed its existence. Unlike the flat, disc-shaped Kuiper Belt, the Oort cloud is a sphere, extending in all directions. It's believed to contain trillions of potential comets, a treasure trove of icy bodies, patiently waiting for a nudge to send them hurtling towards the inner solar system. Both the Kuiper Belt and the Oort cloud are incredibly cold, preserving the primordial ices within their inhabitants. The low temperatures and immense gravitational pull of the outer planets keep these regions stable, allowing the comets to survive for billions of years. Comets are like time capsules, frozen relics from the early solar system. Their icy cores hold clues about the conditions present when our solar system was just beginning to form. By studying them, we can learn more about our cosmic roots and the processes that have shaped our solar system. These frigid, distant regions are the cradles of comets. Just like a recipe, comets have their own unique set of ingredients. Imagine you're in the universe's kitchen. You're about to prepare a cosmological feast, and the main dish is, you guessed it, a comet. What are the ingredients you'd need? Well, the most fundamental ones are ice, rock, and organic compounds. Let's start with the ice. Now this isn't your ordinary freezer ice, we're talking about cosmic ice made up of water, carbon dioxide, and even methane. These icy substances are found in the frigid regions of space, where temperatures are so low that these gases solidify. These ices form the nucleus of the comet, the solid core at its heart. Next up is rock. Comets are sometimes described as dirty snowballs for a reason. The ice in a comet is mixed with dust and rocky material. This rocky substance isn't just one thing though. It's a medley of minerals and silicates, a cosmic cocktail of microscopic particles. It's this mixture of ice and rock that gives comets their solid structure. Now the final ingredient is a touch more exotic: organic compounds. This might bring to mind life as we know it, but in this case we're talking about simple molecules like methane and ammonia. These compounds are believed to be some of the basic building blocks of life, and finding them in comets supports the idea that these icy travelers could have played a part in seeding life on Earth. So, how do these elements come together? Well, in the cold outer regions of the solar system, these ingredients coalesce. The ice acts like a glue, binding the rocky particles together. As more and more material gathers, the comet grows, forming a solid nucleus surrounded by a cloud of gas and dust, known as a coma. With these ingredients, the universe concocts a comet. It's a cosmic recipe, millions, even billions of years in the making. Each comet, a unique blend of ice, rock, and organic compounds, carrying the secrets of our solar system's past within its icy heart. From their icy homes, comets embark on a journey to the heart of our solar system. But what propels these cosmic voyagers on such a daring expedition? The answer lies in the dance of gravity. In the outer reaches of the solar system, a serene ballet of celestial bodies is perpetually in motion. Occasionally something disruptive might happen, perhaps a nearby star passing or a subtle shift in the gravitational tides. These disruptions can send our icy traveler hurtling towards the sun. As the comet journeys inward, it begins to feel the sun's increasing warmth. This is where the magic starts to happen. The comet, once a frozen relic from the dawn of the solar system, begins to transform. The increase in solar heat causes the ices within the comet to vaporize, creating what we call a coma, a cloud of gas and dust that surrounds the comet's nucleus. As the comet continues its inward journey, getting closer and closer to the sun, the solar wind, a stream of charged particles emitted by the sun, pushes against this coma. This interaction results in the formation of two distinct tails. One of these tails, made of dust, reflects sunlight and often appears yellowish-white to our eyes. The other tail, composed of ions or charged particles, interacts with the solar wind and points directly away from the sun. This ion tail can exhibit a beautiful blue hue. So, from a quiet existence in the outer solar system, the comet transforms into a radiant voyager, lighting up our skies and captivating our imaginations. But remember, this journey is not without peril. If a comet ventures too close to the sun, it could meet a fiery end, breaking apart under the intense heat and gravitational pull. This epic journey gives us the celestial spectacle we know as a comet, a breathtaking display of transformation and tenacity, brought to life by the dynamic forces of our solar system. Just as all things in the universe, comets have a life cycle. This cycle is a fascinating journey, a cosmic ballet that unfolds over thousands, if not millions of years. The first stage is formation. Comets are born in the frigid outskirts of the solar system, in regions known as the Oort cloud and the Kuiper belt. These areas are like cosmic nurseries, teeming with a mixture of ice, rock, and dust. When a disturbance, perhaps caused by the gravity of a nearby star, nudges one of these icy bodies, it embarks on a journey towards the sun, marking the beginning of its life as a comet. The second stage is the approach. This is when the comet starts its inward journey towards the sun. As it gets closer, the sun's heat begins to vaporize the ice in the comet, creating a glowing envelope of gas and dust known as the coma. The solar wind pushes this material away from the sun, forming a tail that always points away from the sun, no matter which direction the comet is moving. Then comes the perihelion, the third stage of a comet's life cycle. This is the point in the comet's orbit when it is closest to the sun. The intense solar heat at perihelion causes the comet to lose mass rapidly, creating a spectacular display of light and gas. This is often when we on Earth get the best view of a comet. Finally, there's decay. After reaching perihelion, the comet begins its long journey back to the outer solar system. Over countless orbits, the comet loses more and more of its icy material. Eventually, it may disintegrate completely, becoming a cluster of small, rocky bodies. Alternatively, it might survive the journey and return to the outer solar system, only to begin the cycle anew after a long period of dormancy. In their life cycle, comets encapsulate the dynamism and transience of our universe. They remind us of the vastness of space, the power of the sun, and the fleeting nature of celestial spectacle. Beyond their celestial beauty, comets have left a lasting impact. These icy travelers have not only dazzled our night skies but also deepened our understanding of the cosmos. Comets are time capsules holding ancient secrets of our solar system's early days. Studying them provides valuable insights into the formation and evolution of our celestial neighborhood, but their legacy stretches beyond scientific knowledge. Comets might have played a vital role in the story of life itself. They are believed to have delivered a significant portion of Earth's water and even organic compounds, the building blocks of life. Each comet that passes by could be a reminder of how life on Earth might have received that initial spark. So, the next time you see a comet streak across the sky, remember the incredible journey and legacy it carries. It's not just a beautiful spectacle but a cosmic courier, delivering pieces of the universe's history right before our very eyes.